Hi friends, welcome back. Today we are going to solve LeetCode problem 820 short encoding of words. Before we start looking into the problem statement and a couple of examples and solutions, I just want to mention that my channel is dedicated to help people who are preparing for coding interviews and Java interviews. On my channel, there are over 200 solved problems which were previously asked coding interview questions by big tech companies like Amazon, Apple, Google, Facebook, Microsoft, Yahoo, and many other companies. And those were handpicked problems to cover all the different varieties that comes into coding interview questions, such as dynamic programming, graph problems, binary search tree, linked list, string related interview questions, BFS, DFS, matrix related interview questions. So if you are preparing for Java interviews or coding interviews, please subscribe to this channel. This channel can be of definitely help in your job interview preparation. So please subscribe it. So let's look into this problem statement first. A valid encoding of an array of words is any reference string S and array of indices such that words.length is equal to indices.length. The reference string S ends with hash character. For each indices I, the substring of S starting from indices I and up to but not including the next hash character is equal to words I. Given an array of words, return length of shortest reference string is possible of any valid encoding of words, right? So they have given us these two examples. So let's take this example over here. So let's first take a look here and then we will go into the whiteboard. So for example, we will be given array of different words and we have to find out the length of shortest reference string, right, of valid encoding. So for example, if they have given us that this is the valid encoding string for all these words, and why it is a valid encoding string, because it covers time. As you can see, time is one word, bell is another word, and me is the word that is already covered here as the substring that is ending at this time word, right? This is the substring should be at the ending characters basically, right? So that's why time hash bells hash, it is a shortest reference string, right? And because it is found by this valid encoding, right, time hash and bell hash. So let's just go over the here into the whiteboard. So let me just take a pen here. So as you can see, we have seen this time, me and bell example. So as you can see, like in this example, right, time, how we have formed the encoding string is time, then we put hash, right, hash, and then we put bell here, right, bell, bell, and then again hash here, right? So this is the way we formed that reference string. And why this string is a valid string is because time word is already here, so time is covered, bell is also covered, bell is here, time is here, and the word me, which is a substring which is ending in one of these encoding, right? So it is a valid here, so we can take this also. So total characters are 10 here, right? If you count 4 plus 4 plus 2 hashes, so 10 is the length that we have to return, right? So similarly, if we take this another example, let's say we are taking this another example here, right? So let me just take this out. So now we have been given time, me, bell, and loud bell, right? These let's say for example these are the words, so we can form like a loud bell and time, right? Loud bell and time. So LOUD, loud bell, BELL, and hash, right? After this we have to put hash basically in the reference string in the encoding, right? And then word time here, right? So if, and again hash, right? After word time we have to end always the encoding with hash in the reference string. So if we do that, then we have covered loud bell here, we have covered bell also here, right? Because bell is the ending substring of loud bell, right? So it is acceptable, so we have covered it here. Then time we have covered here, the time, and me also we have covered because me is at the ending substring of time, right? So total words will be like 8 plus 4 12 plus 2, right? 8 plus 4 12 plus 2 is 14 right here, for example, right? So to solve this problem of finding the length of short encoding of words, what we will do is we will first sort these words by their length, right? So this is our sorted lengths, right? Then first time will come, then bell will come, and then me will come. And why we are doing sorting reverse way, right? Means maximum length will come first basically, right? And why we are doing it? Because if we do that way, then whenever we want to check, for example, me is shorter than time, right? So when we are connecting like concatenating strings, then we can immediately verify if me is constituting there like in the ending characters of any of the encoded substrings. That's why we have to sort it the way so that the maximum length should come first, right? So that is the reason. And after that we will just go through these sorted words and we will just append it, right? Like for example, we will first time, we will put time, right? Then this one, right, in the sorted words, then we will put hash, and then we will put bell, right, in this case, and again we will put hash. So bell we will put, and again we will put hash after bell. And then when we are looking at me, right, when we are concatenating, we always wanted to first make sure that it's not already a substring of any of this string, right? Any of these sorted strings. So for example, me is substring of this time, right? Because me is occurring here, right, as the ending substring. So we will not append it basically in that case, right? So this is if we calculate the length of this string, right, then it is 10 basically, right? 4 plus 4 plus 2. So when we are putting, like when we are looking at in each of these words, we will put that in a linked list, right? If it is a valid encoding that we have not seen before, or it is not a substring of any of the encoded words, right, then we will put it in a list. If it's already found as a substring, for example, in case of me, we will not put it into the substring, right, into the list of strings basically, right? So that is the approach. We are going to solve the short encoding of words problem. So let's look into the implementation quickly, and then we will run our unit test case. So first we are sorting the words array, as I said, by using the length and then comparing with the length as a comparator, and we are doing reversed, right, because we want the maximum length on the top. After the sorting is done, we will create a just encodings list, it's an array list, and we will put the first word in that list, right? Because first word will always be there, right? Because there is nothing you can compare before that. And we will initialize our length to the word 0.length because we already have first word into our array list and into our encodings list. After that, we will start with index 1 and we will go through all these words in the string array, and we will first assign, like we create just suffix found variable boolean, right, and created as a false. Then we will go through all the encodings that we have already found, right? And if the new word I, if it is coming as the ends with, right, we will use ends with of the string. This is a string method, right? So it will if it is ending, we find ends with, then we already found a suffix found is true, and we will just break out of this for loop and we will continue, right, for the next one here, right? So for example, what we are doing here is that in this case of like for example, we let me just take these other colors out so I can reuse this space again. So when we are looking into this, first we sorted, right, then we will put the time into our linked list, right? So we put time word into our linked list. Then second word we put in our linked list is bell, right? Because there is no ends with bell, right? There is no one which is ending with bell, right? And when we are looking at me, then when we will go through each and every word in this list and we will check if it is ends with me is found, right? So here ends with me is found, right? And in this case we will not add into the list basically. So that is what we are doing here. We are checking if ends with is found with any of the encoding in this list, right? then we will just put suffix found is true and we will just break out basically, right? If there is no suffix found, then we will add it to our list and we will increment our length by the words length, right? Words I dot length. So basically, for example, here we incremented our length to 4, right? When we are in added bell, we again incremented our length by 4 plus 4, so now it becomes 8, right? And we when we are looking at word, me is already found as the ending with, so we will not increment, we will not put it into list and we will not increment our length, right? So we are finished with the sorted array, right? So we will just, what we will do is 8 plus this length, 8 plus the length of the array list, like 2 is the length, right? Two words are there, so 8 plus 2, which is equal to 10. So 10 is our answer basically, right, in this case. So that is what we will do here. So length is the length, which is 8 here, right? 8 length that we have found, and 2 is the size of that array list, right? Encoding list dot size. So that much is the, basically you can say, length of the shortest reference string, right, which is possible of any valid encoding. So this is the length which is possible, right? So this is the way we can solve this problem. So we can go ahead and run these examples that's given to us, like time, me and bell. So it should give us 10 as our answer. So we have got 10 as our answer, right? So let us just put one more word here. So let's say it is let's say I have one other word, ball, right? Then it is not like forming any other, like it's not forming any ending encodings, right? Like it's not like me, which is embedded here at the ending, right? So our length will increase by 4 in this case, right? So it will be 4 plus 1, right? So 5 it will be basically. So 4 plus 1, right? Because of the hash, right? Hash also we will put, so ball and hash, so 5, it will increase from 10 to 15 in this case, right? And now if we have another word here, for example balls, right? Then in that case it will be like 6, right? Because so total will be, in this case, is uh, 21, right? Because balls, right? So let's just take care of this. So this, all these words will be attached, right? 1 2 3 and 4. So 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 5 is 17, right? And total words will be 17 plus 4, which is 21, right? So 21 will be there basically. So let's just go ahead and let's just run this, all these examples here. So as we can see, 10 and 2, so our unit tests are passing here. So we can just go ahead and submit our solution. So our solution got accepted by LeetCode. So this is the way we can solve short encoding of words problem with the help of sorting. We will do, first we have done sorting of the words and we made sure that the maximum length words will be in the first, right? And then we just created a linked list and we went through all this linked list after the sorting is done, and we, before we add it to the list, we always will make sure that we will check all the words, and if in this word, let's say for example me, is appearing in at the ending substring, right, then we will just not add it to the list and we will not increase length for those words, right? For example me here. So that is how we can solve this problem. The code is very simple to understand. I will put this into the GitHub repository and give you the link at the description. If you haven't already checked my playlist on my channel for LeetCode and Lintcode solutions, please check it now. It has over 200 solved problems which were taken by previously asked coding interview questions by Amazon, Facebook, Apple, Microsoft, Google, Yahoo and many other companies. and those questions are like from different varieties, right? Dynamic programming, graph, binary search trees, binary search related problems, string related coding questions, then linked list related problems, BFS, DFS, matrix related coding interview questions are also there. So please, if you are if you are preparing for Java interviews and looking for some coding exercise that are good for practicing and for the interviews, then please subscribe to this channel. This channel can definitely help you in your job interview preparation, and your subscription is really important to us because that is the way the video can reach to more people like you who are preparing for coding interviews and Java interviews. They can also watch these solved problems and they will understand the approaches and how to approach any coding interview questions. So please subscribe to the channel, and thanks for watching this video.